Our subject motto is Mathematics Made Simple. Let's go to our lesson 18, which are matrices. What is a matrix? A matrix is a systematic arrangement of numbers or letters in rows and columns. Rows are horizontal or flat. Columns are vertical or upright. The numbers or letters in a matrix are called elements or entries. Let's look at the order of a matrix. Generally, if a matrix has m number of rows and n number of columns, then the order of that matrix is m by n, which is m times n. Let's go to an example. The example is saying, state the order of the following matrices. A, we have entries 3, -1 and 2 in the first row, since rows are flat. Horizontal means flat, and columns are upright. So we have 3, -1 and 2 in the first row, 4, 0 and 6 in the second row, 3 and 4, that's the first column, -1 and 0 is the second column, 2 and 6 is the third column. Therefore, the order of the matrix is a 2 by 3 matrix. We go to another example. We have 2 and 2 in the first row, 4 and 8 in the second row, 2 and 4 in the first column, 2 and 8 in the second column. Now, when you have the same number of rows and the same number of columns, it is called a square matrix. So this is a 2 by 2 square matrix. We continue. We have 9. 9 has 1 row and 1 column. Therefore, it is a square matrix. So we have a 1 by 1 square matrix. We continue. We have that matrix. First row has 8, 0 and 5. Those are the entries. Second row has 7, 3, -2. Third row has 6, 9 and 1. First column has 8, 7 and 6. Second column has 0, 3 and 9. The third column has 5, -2 and 1. Since it has the same number of rows, it has 1, 2, 3 rows and 3 columns. This is a 3 by 3 square matrix. We continue. We have E, which has the entries -1, 4 and 5. Now, since it has 3 rows and 1 column, this one is called a column matrix. So this one is a 3 by 1 column matrix. We have F, which has entries 6, -5 and 4. It has 1 row and 3 columns. So this one is a row matrix. This one is a 1 by 3 row matrix. Now, when you are looking at addition and subtraction of matrices, addition of matrices is commutative, meaning you can put them in any order when you are adding and you still get the same answer. Subtraction of matrices is not commutative. When you put them in any order, you are not going to get the same answer. Let's go to an example. We are given that example, which is saying, given that A is equals to 3 and 2 in the first row, -1 and 6 in the second row, B is equals to 7 and 3 in the first row, 4 and 2 in the second row, and C has entries 0 and 1 in the first row, -2 and 3 in the second row. Find A plus B. Find A plus B. So what we are going to do is to say A plus B is equals to, where there's A, we are going to replace the matrix A. Where there's B, we'll substitute the matrix B. Now, when you are adding matrices, you add them according to the position of the entries. The first entry in the first row should be added to the first entry in the first row. Second entry in the first row plus second entry in the first row. First entry in the second row plus the first entry in the second row. Second entry in the second row plus second entry in the second row. We'll add them like that. So we are saying 3 plus 7, and then we have 2 plus 3. We have -1 plus 4 and 6 plus 2. Now, if you add 3 plus 7, you are going to get a 10. 2 plus 3 is giving us a 5. -1 plus 4 is giving us a +3. 6 plus 2 is giving us 8. We continue. We have B plus A. B plus A is equals to, where there's a matrix B, we replace the matrix for B. Where there's A, we'll replace that matrix. and then we are going to add them according to their corresponding entries. So we have 7 plus 3, that 3 plus 2, 4 plus -1, and 2 plus 6. So when we add that, we are getting 10 and 5 in the first row, 3 and 8 in the second row. Now if you look at our answer for A plus B and our answer for B plus A, the answer is the same because they are commutative. We continue. We have A minus B. There where we were adding matrices, that is how we are going to subtract them. We'll subtract them according to their entries. First entry minus the first entry in the first row. Second entry minus the second entry in the first row. First entry in the second row minus the first entry in the second row. Second entry minus the second entry in the second row. Let's do that. So we have 3 minus 7, 2 minus 3, -1 minus 4, and 6 minus 2. Our answer will be -1 and -4, -1 in the first row, -5 and 4 in the second row. We continue. We have D, B minus A. Where there's B, we'll substitute the matrix for B, and where there's A, we'll substitute the matrix for A, and then we are going to subtract them according to their corresponding position. So we have 7 minus 3, 3 minus 2, we have 4 minus -1, and 2 minus 6. Our answer is going to give us 7 minus 3 is giving us a 4, 3 minus 2 is giving us a 1. When you have a minus and a negative, it is the same as 1 plus. It is the same as a positive. So we have 4 plus 1 is giving us 5. 2 minus 6 is giving us a -4. If you look at the answer for C and D, they are not the same because subtraction of matrices is not commutative. We go to our last example. We have A minus C. So where there's A, we'll replace the matrix for A. Where there's C, we'll replace the matrix for C, and then we are going to subtract according to their position. So we are going to say 3 minus 0, 2 minus 1, -1 minus -2, and 6 minus 3. So when we do that, we are going to find that when you have a minus and a negative, it is the same as plus. So we have 3 minus 0 giving us 3, 2 minus 1 giving us 1, -1 plus 2 is giving us a +1, and 6 minus 3 is giving us a +3. As simple as that.